SOHC, and DOHC. These represent the valve configuration inside an engine head to control the action of the valves. Though these configurations are renowned for their superior performance, both have some significant differences. SOHC stands for Single Overhead Cam. This type of valve configuration utilizes only a single camshaft for operating both intake and exhaust valves. DOHC, or Dual Overhead Cam, on the other hand, utilizes two independent camshafts for the operation of the intake and exhaust valves. Let's have a look at the SOHC configuration. An SOHC engine head is packed with intake and exhaust valves, rocker arms, rocker arm shafts, and a single camshaft. The camshaft is designed in such a manner that the cam lobes could push the rocker arms at corresponding timings to open the valves. The return springs ensure that the valves lift back afterwards and keeps tension back on the lobes. SOHC design typically allows a 2 or 3 valves per cylinder configuration, where usually 1 valve for intake and 1 for exhaust, or 2 valves for intake and 1 for exhaust. However, current industrial competencies allow production of 4 valves per cylinder configuration using SOHC. Due to the reduced count of parts, the design complexity and manufacturing cost is comparatively low for SOHC engines. Since the mass of the valve train is lesser in such a configuration, SOHC engines tend to produce more torque towards low to mid RPM and provide improved fuel efficiency. The DOHC was later introduced with improved volumetric efficiency for an internal combustion engine. In this configuration, the head is packed with intake and exhaust valves, cam followers, and 2 independent camshafts. DOHC uses 2 separate camshafts per bank of the cylinder head. This allows all the cam lobes to directly operate the valves rather than using rocker arms as in SOHC engines. Here also, the return spring ensures that the valves lift back and keeps the tension on the camshaft lobes. DOHC usually implements a 4-valve per cylinder configuration, 2 valves for intake and 2 for exhaust. This configuration has a better valve lift, resulting in improved airflow through the combustion chamber. With less airflow restriction, the DOHC is even capable of generating more horsepower out of smaller displacement. Though this configuration can provide better top-end power, the design complexity and increased components result in more weight and a higher cost of production. When it comes to choosing between SOHC and DOHC engines, both have its own pros and cons. Let's look at some points briefing the presentation. SOHC uses a single shaft to drive all valves. Fewer components make less in weight. Better torque at low to mid-range RPM. Cost-effective at manufacturing. Fuel efficient due to fewer parts consuming energy. Camshaft being at the center denies the ideal location for spark plugs. DOHC uses 2 independent shafts to operate the valves. Complex design and increased production cost. Improved volumetric efficiency with better airflow. Makes the engine capable of revving up to higher RPMs. Better top-end torque and increased horsepower. Capable of implementing efficiency-enhancing technologies like VVT.